Hello. Today I would like to present the paper that I submitted for this workshop. It's called Cloud Enabling Educational Platforms with corc. It's made by me, Rasmus Munk, and my two collaborators, David Marchant and Professor Brian Vinter. Me and David are both from the University of Copenhagen, where we work at the e-science department at the Niels Bohr Institute. So a bit about the background for this paper. So at the University of Copenhagen, we have a number of science IT services. A couple of highlights here is our electronic research data archive, which is our data management platform for all teachers, researchers, and students, and staff in general. Then in addition, we have the data analysis gateway, which is mostly used by also researchers, teachers, and students to do interactive analysis. So it's powered by JupyterHub to provide this interactive programming environment. And then in addition, we have the two Modi and Heel, which are variants of this, but they have certain specialty. So Modi is for cluster computing, so it's more focused on multiple compute nodes working together to solve a problem. And the Heel is about neural network training and machine learning in general. Whereas we also have the Epsilon service, but that is more towards teacher-student interactions and giving feedback to students. So specifically in this paper, we talk about the data analysis gateway because that is our main focus, in that it's a service that's very crucial to us since it allows this interactive programming and it allows our teachers to teach the students how to program and how to basically do their analysis in a readable way also to others. So for example, here on the right, we have an example of a Jupyter Notebook, which is from the course that introduces computer science to physics students. And here they have it's the week 1 exercises where they have a number of tasks that they should carry out and just get a feeling for how it is to program in Python. So this is all good, but what we're sort of missing on this service is the possibility to gain access to more advanced resources, such as accelerators like a graphics card, because currently with our internal resources, we only have access to CPU-based compute nodes, and so we can't accelerate these applications, particularly machine learning tasks and algorithms, as much as we want to. So this is also very, a big request by both the teachers, but also the researchers, that they want access to more advanced capabilities such as accelerators. So to provide this, we looked at a number of different options that would enable us to provide this. And from looking at the existing cloud platforms, we could identify 3 providers that would enable us to both get Jupyter Notebooks, but also access to GPUs. And that would be Kaggle, Google Colab, and Azure Notebooks. But because of their terms of service, we would only gain access to them for a limited amount of time and with a limited amount of inactive before a particular session would get killed. And the most generous one we could find is the Google Colab one that would give you 12 hours of session time before it would get terminated. But that even degrades over time the more you use it, as long as you're using the free option. So instead of this, we decided that we would enable our own internal service, the data analysis gateway, to be able to utilize cloud resources externally by orchestrating cloud resources at a public provider such as either AWS or Oracle Cloud. So in order to do this orchestration, we decided on using the Cloud Orchestrator, which is an internal developed cloud orchestration framework, which enable us to both define the cloud providers that we want to support, how they're configured, how we authenticate against them, and potentially also be able to schedule other sorts of computational tasks on these resources besides running a Jupyter Notebook. So the Cloud Orchestrator enables us to both orchestrate a resource, such as either a virtual machine or a container, or it enables us to submit tasks on those cloud resources that have been orchestrated. So it is oriented towards supporting potentially many different providers. It's extendable in that way. And the same goes for how you configure the resources that you orchestrate. So currently we allow you to orchestrate the resources through Ansible. You're the default is to authenticate against resources with SSH, and currently the scheduler that's implemented, if you want to do other tasks such as submit a lot of batch jobs, then we enable you to use a Kubernetes cluster on the provider. But all of these different components are extendable, as it states. Both the orchestrators, the configuration, the authentication, and the schedulers can be implemented to serve a specific need. So looking towards the result of this paper. So what do we achieve? Well, we cloud enabled the data analysis gateway, where it makes us able to select either whether we want to spawn a particular notebook at the Oracle Cloud Infrastructure or at the University of Copenhagen. Specifically, we were able to do this by the introduction of the JupyterHub MultipleSpawner, which is inspired by an existing one called WrapSpawner. So by using this, we're able to dynamically select which provider we want to use and which resource type we want to schedule on that provider. And this is enabled by having independent configurations, so you don't rely on the JupyterHub configuration, which is static after the application has been launched. So this enables us to, in the future, dynamically add different providers without having to affect the availability of the service while it's running. And through JupyterHub MultipleSpawner, here we have an example of the configuration. We're able to define which spawner we want to use, how the resource spawned from that spawner is configured, and how we authenticate against that resource. And in addition, we also are able to select which sort of resource type that should be scheduled. So over here on the right, we can see that we're scheduling a virtual machine that is based on the Oracle image called Oracle Linux 7.8. To benchmark this, we selected a particular notebook to see if we would get any sort of speed up from running the application on a GPU-powered machine compared to a CPU-based compute node. And here we've used the TensorFlow 2 Quick Start for Beginners, which is just a basic neural network that classifies images. That's the one that's being trained based on the MNIST dataset. And as we can see here on the right, we have the comparison between running it natively on our internal data analysis gateway and then utilizing an Oracle-powered GPU-based compute node. And on average, we, as expected, will gain a 2.8 times speed up on this sort of application. So the conclusions from this is that we enabled the data analysis gateway, at least in our test setup, to utilize external cloud resources and dynamically schedule them and dynamically select between either the Oracle Cloud provider as the endpoint or as the host of our resource, or choosing our internal cloud to schedule and provide these JupyterHub notebooks. We enabled this through the introduction of the MultipleSpawner, which allows you to define these different providers and utilize different spawners to schedule notebooks in different ways. And by utilizing the corc framework, we were able to then make sure that these resources were scheduled ahead of time, they were configured correctly, and that the JupyterHub could authenticate against them. And in the end, we will then eventually be able to enable the cloud resources to be used on our live data teaching platform compared to just running it in our test. So for the future, we would like to expand the support of corc so that it also supports different cloud providers. And we are partially already implemented the support for utilizing AWS. We want to also launch, of course, the MultipleSpawner on the live data analysis gateway, and thereby expanding the amount of users that can gain access to it, and also test it in a much greater environment with many more users. Also, we want to expand corc so that it can support a grid of clouds, meaning that we can be multiple organizations that share resources amongst us. So that, for instance, could be the University of Copenhagen, the University of Lund in Sweden, and Aarhus University in Jutland. So if we could establish such a grid, we will be able to dynamically share resources among us, and then potentially be much more efficient in how we run, both our teaching but also our research. Then we also want to investigate whether we have other science IT services that could potentially benefit from, being cloud enabled or gain access to additional capabilities outside of the university itself. So with that, I'd like to acknowledge the different organizations that have funded this project or provided funding for this project. That includes the European training network called Mummering, and I would like to thank to Oracle for providing us with the cloud credits that enabled us to develop this framework to begin with. So yeah, thank you.